Good day, I'm Jani Erasmus, a civil engineering student at UNISA. With this assignment, I'll be asked to do a design to upgrade the existing R33, section 13, from kilometer 60.8 to kilometer 63. This road section is located in the Limpopo province of South Africa. This road is classified as a Class 2 rural road. Section 13 of the R33 is close to the town Valwater. Here you can see the section of the road we were looking at. The total length of the upgrading road is 2.2 kilometers. In the presentation, will you have a look at the design criteria to upgrade the existing road to a dual carriageway. The existing road is a single carriageway with one lane in each direction. There are existing intersection crossings on the R33 giving access to the farms, companies and a filling station, and also a few informal intersections giving access to the homes next to the road. We will need to consider this into the new upgrade. Firstly, have we received some information of the traffic count that was done in 2019. I'm going to design the new upgrade to last for the next 30 years. In 2019, we was working with 5,581 vehicles and 638 heavy vehicles per day. In 30 years' time, we were working with 31,160 light vehicles and 3,562 heavy vehicles per day. There is a few existing findings on site, like the existing road is graded on ground level. There are severe problems with silt and sedimentation. There are open drains and culverts. Passing trucks parking on a gravel shoulder. There are a very high volume of pedestrians walking on the road shoulder. There are no existing public transport. Some cases of speeding when entering the town were noticed, and the existing pavement is close to its end of life. First, I have done some design calculations to determine the current and future traffic volumes. I also have done calculations for all horizontal alignment calculations, which includes tangent length, minimum curve radius, changes of the beginning and ending of the curves, skid resistance and super elevation, stopping side distance, barrier side distance and passing side distance. For vertical alignment, have I determined the K value of the vertical curves and the curve lengths. Here you can see my design. This is the layout drawing of the whole road section. This new design is still inside the road reserve of a Class 2 road, which is 30 meters wide. I have added 2 bus stops close to town. There is a pedestrian crossing to cross the road, and for traffic calming, will they construct speed bumps in front and behind each pedestrian crossing. Our new road will be classified as a Class B, interurban, collectors and real road. The new upgraded road section will look as follows. We will have a double carriageway with 2 lanes in each direction. A raised island will be constructed between the 2 carriageways to prevent unsafe movements and U-turns. The layer works will be a 40A asphalt wearing course on a 150mm G2 base layer, on a 200mm C4 base layer, and I have calculated that the subgrade need to be of a minimum a G7 material. For proper stormwater drainage, will the road surface be sloped with a 2% fall to the left with a gutter and curb installed on the edge. Right behind the curb will there be a 1.5 meter wide raised walkway sloped with 2% towards the road. Curb inlets will be installed in strategic places and also at a maximum of 200 meters from each other on both sides of the road. The curb inlets will be connected to stormwater pipes of a minimum diameter of 5 to 5 millimeters and will be below the road level and drain the stormwater on the western side of the road. More in-detailed stormwater studies and design will be done further through this project. I have used TRH17 to design the upgraded road. The road will have a speed limit of 60 km per hour like the existing one. According to TRH17, the stopping side distance needs to be below 80 meters. Mine is calculated as 43.5 meters. According to TRH17, the passing side distance needs to be a minimum of 420 meters at a design speed of 60 km per hour. Mine was calculated above 500 meters according to the Civil 3D program I've used to design the road. For vertical curves with a speed limit of 60 km per hour, do we need to meet the standard with a K value of 16. I have designed my vertical curve with a minimum K value of 100. The reason for this is to smoothen out the vertical curves to give a smoother ride. I am allowed to design vertical curves with a minimum length of 100 meters. My minimum vertical curve length is 105 meters long. So in short, do I meet all the TRH17 standards with my new design? I have used Civil 3D to do my road design. I'm going to show you a few screenshots of the designing process. We have received a high resolution photo to work with, and we also received the center line and start and end points of the upgrading section. From here, I have added an alignment. From the alignment is a surface profile created, also known as a long section. Here you can see the long section of the road. From here have I created an assembly. I have created a corridor from the assembly. A few steps later we come close to the final product. Here is the road with contour lines. I have added the intersections with the intersection tool of Civil 3D and added them on the exact intersection places. Civil 3D is capable to identify the storm water flow direction on the road. Here you can see the water will flow to the outer edge of the road as designed. And then, just a side distance check, the full report can be seen in my assignment. Here is the final design of the road done by using Civil 3D. This visual drive is done in a fast lane driving at 60 km per hour. During this drive, will you see the middle raised island will be broken at the intersections to be able to cross the road. On the right hand side, can you see that we will cut into the existing NGL level and make some embankments on the edges. This is to give a smoother ride over the crest curves in this area. This concludes my design. Thanks for watching. I will update you during construction with any updates and progress on site.